All right, today we are doing lesson 5, which is our last lesson for long division, and we are going to be working on repeating decimals. So a repeating decimal is a decimal that repeats the same digit or digits forever. So if you look at these examples below, our first one we have 41.33333. These threes would go on forever and ever. So instead of rounding or just continuing to write the threes forever, we can write this as 41.3 with this line over the 3, which shows that this digit is going to be repeating forever. For our next example, 90.818181, so on forever and ever. We can show that that 81 continues to repeat by writing this as 90.81 with that repeating decimals line over the 8 and the 1. This shows that my 8 and my 1 keeps going in a pattern forever and ever. For my next example, 0.677777, the 7 is going on forever. I could write this as 0.67 with my repeating decimal line over the 7 to show that this 7 is continually repeating. So notice that in this example I have my line over my 3 because the 3 continues to repeat. In this example I have the line over the 8 and the 1 because both the 8 and the 1 repeats. In this example I do not have the line over the 6 and only over the 7 because I have 1 6 and my 7 is my only digit that repeats. Okay, so the steps to complete this is exactly the same as your previous long division notes. So we have divide, multiply, subtract, bring down, and then repeat. We have the same mnemonic here on the front for you as a reminder. Does McDonald's sell burgers? So you're going to be doing the same process. Okay? Make sure you have your multiplication chart out because you are going to be using that to list your multiples, just like in the other lessons as well. So example 1, I have 5,231 divided by 15. Okay, so just like in all of our other examples, I'm going to start by rewriting my problem on the grid. 5,231. Okay, and off to the side over here, I am going to list my multiples of 15 by using my multiplication chart. Okay, so I'm going to list the first few, 15, 30, 45, 60, 75, 90, 105, 120, and 135. Okay, just so that's there for me to reference. Okay, so 15 goes into 5 0 times. 5 is too small. 15 goes into 52 3 times. Okay, my next step, 3 times 15 is 45. Going to subtract. 52 minus 45 is 7. I'm going to bring down my 3. Okay, 15 goes into 73 4 times without going over. 4 times 15 is 60. When I subtract, I am going to be left with 13. And then I'm going to bring down my 1. 15 goes into 131 8 times. 1, 2, 3, 4, 5, 6, 7, 8. 8 times 15 is 120. When I subtract, I'm going to be left with 11. Okay, just like in our previous lesson, we're not working with remainders. Okay, so I'm going to extend this line over here. I'm going to add a decimal in under my line and in the quotient. And I'm going to add a 0. Remember, adding a 0 does not change the value of this number. So I'm going to bring down this 0 to make it 110. 15 goes into 110. 1, 2, 3, 4, 5, 6, 7 times. So I'm going to put my 7 after my decimal. 7 times 15 is 105. When I subtract, I will be left with 5. I still have that remainder, so I'm going to add a 0 and bring down my 0. 15 goes into 50. Whoops, I'm going to do this in purple. 3 times. 3 times 15 is 45. When I subtract, I'd be left with 5. Still have that remainder, so I'm going to add a 0, bring it down. 15 goes into 50 3 times. 3 times 15 is 45. When I subtract, I'm left with 5. And as I can see now, I'm developing a pattern, okay? I keep having a remainder of 5, so I bring down a 0. 15 goes into 50 3 times, so then I'm left with 45. When I subtract, my remainder is 5. So I know that I'm going to continue to see the same pattern forever and ever, which means that my 3 is going to continue to go on forever and ever. So I can stop right there, and I'm going to do, instead of an equal sign, I'm going to do this squiggly equal sign because it approximately equals 348.73, and I'm going to put that line over the 3 to show that this 3 would continue on forever and ever. Okay, and that is my final answer. For example 2, I have 5,234 divided by 11, so I'm going to start by rewriting in my grid. Okay, and I'm going to use my multiplication chart over here to list my multiples of 11 down the side. So I have 11, 22, 33, 44, 55, 66, 77, 88, 99. Okay, so to start off, 11 goes into 5 0 times. 11 goes into 52, start with this color, sorry, 4 times. 4 times 11 equals 44. When I subtract, I'm left with 8. I'm going to bring down my 3. 11 goes into 83 7 times. 7 times 11 equals 77. When I subtract 83 minus 77, I'm going to be left with 6. I'm going to bring down my 4. 11 goes into 64 5 times. 5 times 11 is 55. When I subtract, I'm going to be left with 9. Okay, again, I can't have that remainder in there, so I'm going to extend my line. I'm going to add my decimals and bring down a 0. 11 goes into 98 times without going over. 8 times 11 is 88. When I subtract, I will be left with 2. Still have that remainder, so I'm going to add a 0 here at the end. 11 goes into 20 1 time. 1 times 11 equals 11. When I subtract, I'll be left with 9. Add my 0 to the end, make this 90. 11 goes into 90 8 times. 8 times 11 equals 88. When I subtract, I'm going to be left with 2. I'm going to bring down a 0. 11 goes into 20 1 time. 1 times 11 is 11. When I subtract, I'm left with 9. Okay, so I can see this pattern developing. I have 2 left over, then 9 left over, then 2 left over, then 9 left over. So I'm going to continue to see this pattern of 8, 1, 8, 1. This is going to go on forever. So again, my approximate answer is 475.81, and I'm going to put that line over the 8 and the 1 because both of those digits are repeating forever and ever. Okay, go ahead and try the you try on your own.